Okay guys, so what we have here is a GCSE titration calculation, and these questions can be tricky. And what I mean by tricky is there is lots of information and students think, oh my god, where do I start? How do I begin this question? The problem is this can be either very easy for you or very difficult if you have no idea what you're doing. So let's try and break it down and let's make these questions as easy as possible. The first thing is we need to understand what the question is asking us. We know that this is a titration calculation and there is a neutralization reaction taking place. How do I know that? Well, sodium carbonate is a base and it's reacting with nitric acid. Okay. Now, in the question, we have our, well, let's just read it actually. 25 centimeters cubed of a 0.124 molar decimeters cubed of sodium carbonate. So we have volume because we know that 25 centimeters cubed is a three-dimensional unit. That tells us the volume of our sodium carbonate, which is the base, and it is also got a concentration of 0.124. So let's do that. Let's make that a little bit more neater looking. And that is going to be our C. Why? Because it's in moles per decimeters cubed. Now it's neutralized by 23.6 centimeters cubed, which is the volume again, but this time of our acid, nitric acid. Now, if you guys have seen the titration setup, it could be something that looks like this. So you have your burette and you have your conical flask. Inside your conical flask, you have your volume of base. So in this case, we have Na2CO3. And in this burette, which is going to be titrated with the base, we have our HNO3. Okay, these two react together, and so we know that we've got 23.6 centimeters cubed volume of nitric acid, and we also know that we have 25 centimeters cubed of our sodium carbonate and a concentration of 0.124. Now, this is just for you guys to really understand what is going on in this experiment. Well, we need to find out how much concentration, which is of our HNO3, is in this burette. We don't know what it is yet. We're going to work it out. So let's do that. So what we have here then is we have our concentration and we have our concentration of sodium carbonate as well. And we're going to work out then from what we know and then work backwards to what we don't know. So V is 25 centimeters cubed of Na2CO3. Now, because we've got it in centimeters cubed, we need to change that into decimeters cubed, don't we? So let's divide that by 1,000. And we get our decimeters cubed answer of 0.025 decimeters cubed. Now, what's really important here is to understand that we need to have the volumes and the units the same, because if I've got my concentration in moles per decimeters cubed, then I must have my volume in decimeters cubed as well. So we are using the same units. It will then work out and be calculated accurately. All right, keep that in mind, especially for any type of calculations, whether it be in physics or chemistry. Let's now work out what we can do with these two. So we've got this concentration, we have the volume. And I know that these two are related by the equation number of moles equals concentration times volume. Right? There's two ways to work out the number of moles. Either use the mass calculation for number of moles, or use the concentration calculation for number of moles. So this is the concentration calculation for moles, which is concentration times volume. And in this case, we have 0.1 0.24 moles per decimeters cubed multiplied by our 0.025 decimeters cubed. And you can see here very clearly that these 2 decimeters cubed will cancel out. If you're good at maths, you can see that, but don't worry, it just tells us the number of moles which is left and remaining. And that is the following. And let's work it out. 0.124 multiplied by 0.025. Answer is 0.031. So let's write that down. 0.031 mole of our sodium carbonate, Na2CO3. Okay, brilliant. So we've done the first part of our bullet points here, which is finding the number of moles of sodium carbonate. Tick. The number of moles of nitric acid in 23.6 centimeters cubed. Now, let's look at our equation, because we've got, for every 1 mole, well, you should just look over here, please. 1 mole of Na2CO3, we have 2 moles of HNO3. And that means that if I do this, we have a 1 to 2 relationship. Okay, so 1 mole of Na2CO3, let's write down over here. For HNO3, we have 0.031. And of course, if I've got 1 of these and I've got 2 of these, I have to multiply by 2 to get my number of moles of HNO3. And that will give me, therefore, times it by 2, which gives us an answer of 0.0062. So we get an answer of 0.0062. I've just seen I made a mistake over here. That should have been 0.0031, isn't it? So that's fine, as long as you correct yourself over here and then add another 0 over here. Let's do that again, make it look nice and neat. There we have it. So we know we've got 0.0062 moles of HNO3. Right, so the last part then is thinking about what can we do with getting the concentration, because this is the last part we need. So we found the number of moles of our HNO3, which is there. We have, again, our equation here. And how do I find the concentration? Well, I can rearrange it, can't I? So N equals C times V. If I divide both sides by volume, that side cancels out. And so I've got my concentration, which is C equals N over V. And so that equals, oh, goodness me, let's sort that out. And that should give you an answer of the following. So we've got 0.0062. Divide that by the volume. Now the volume in the question is given in yellow here, isn't it? The volume of nitric acid is 23.6. So the volume equals 23.6 centimeters cubed. Divide that by 1,000, guys. Remember, we have to divide it by 1,000 to get it into decimeters cubed. So it becomes 0.0236 decimeters cubed. And so let's write that down. Let's just scroll down a little bit more so that we've got more space. And so we have to do our last calculation, which is going to be the answer, which is 0.0062. Divide that by 0.0236, which gives us an answer of 0.2627. So let's just write that down. And because we want it in 3 significant figures, guys, we need to look at the three significant figures. So here's 1, 2, 3. And is the fourth digit bigger than 5? Clearly it is. So the answer therefore is 0.263 to three significant figures. And the units are moles per decimeters cubed because we are working out concentration. Okay, thank you very much for listening.